Okay, so we've talked about three techniques so far: simple projection of a grid, volumetric slicing and layering, and then brute force detection of the contour line on the mesh data. Okay, now we're going to talk about a more optimized, or just kind of starting with a simple technique and then adding some smart or clever refinements. Okay, so we're going to start with a relatively low resolution grid. All right, so before I think I was showing a 0.2 or a 0.1, and just to give you an idea, this is 84,000 verts and 150,000 faces, which is on par for a decent dental scan. Sometimes you get 200 to 300,000, but if you take this resolution down to 0.1, you quickly get into the millions of polygons, and that's just cumbersome for computers and not really necessary or feasible. In fact, for demonstration purposes, I'm going to enlarge that grid even more so we can see some things a little bit better. So we're going to go ahead and do an initial projection down onto the object, and I'm going to flip the normals. That's just convention, which way we were projecting the plane, up or down. And when we're looking at this, and we look at this kind of jagged contour, if you look closely, it seems like we might do a lot better if we had a little connection between the grid verts at the areas where the contour of the drop-off didn't match the either north-south or east-west direction of the grid. So for example, if I were to connect those two verts, all of a sudden that this outline down here matches the outline of the model a little bit better. So our first refinement is going to be to triangulate faces that have 3 verts close together and 1 vert long away. So these faces, for example, these faces are well aligned with the edge of the object. So we don't want to triangulate those. That would be unnecessary. But here, these faces, where 1 vert is stretched up, it might be better to slice off this one face. And if we were really smart, we could then merge the 2 triangles that that are created by slicing the bottom one and slicing the top one. But that, I have not implemented that yet. But that's next. So here's what this looks like. We're going to triangulate this, and it's best to look down here along the edge to see the results of that. Okay, so now you can see that the outline of this model looks better. Okay, next concept. Any edges that are significantly longer than the original grid resolution are edges near a drop-off. And a drop-off could have an undercut underneath or just a vertical section. So the next thing we want to do is find any edges that are long, split them, and then reproject them down. And by doing so, we'll selectively add data around where the drop-offs are. Okay, so what I did there is we actually subdivided and then reprojected. So now look down here, you'll see that more points have dropped down onto the grid below. And if I reset the grid by just putting all the points at 0, you can see that we have a lot more data density around the perimeter of the object, particularly where there are drop-offs. Okay, so I'm going to project this back down. Okay, so when we do that, if we do that a couple of times, we'll end up with a fairly accurate representation of the object with all the undercuts removed. The next thing we're going to do is remove degenerate data, which so we can really thin narrow triangles we can dissolve into their neighbors. And so we'll do that. And then we will repeat the triangulation, subdivide and project, remove degenerate. And you can see the good thing here is that we're not adding data anywhere outside of the area of interest, so that the model size starts to stay fairly constant. Okay, and let's turn the wireframe off. What we see now is that our drop-off is much less jagged than it was in the initial grid implementation. Now, unfortunately, error is still concentrated at the corners. But once we get to this point, we can start to do some other tricks to compensate for that error. And that's something that I'll talk about in a future series. But even if we were to reset the grid here, oops, there we go, and look at it from above, if nothing else, we've created a very nice perimeter of this model that we could use for, I'm not sure, maybe adding a base later. Hint, hint. So stay tuned. I'll be making some more videos next week, but these first 3 introductions should give you an idea of what's possible, and hopefully we can kind of move the 3D dental community forward.